Hello everyone, welcome back to my channel InfoSecLab. Today we're going to attempt to the room include, which is part of the TryHackMe's web app pen testing, assesses your skill on advanced server-side attacks. If you haven't gone over these rooms, I would recommend you go through this room first to get the basic understandings of these server-side attacks. Okay, without further ado, let's get started. I've already started my attack box and the target machine. Now I'm going to add this one to the host file. As usual, we're going to run an nmap scan on the target machine to see the open ports and their services. The command is nmap-a, which is all the services, and the version target is include TryHackMe. Let it run for a while. In the meantime, I would like to talk a little bit about the tools we use in this room. Usually, we're going to be using Burp Suite, but I want to introduce you to Caido, which is another tool that we use in web app pen testing. The reason I recommend using this one because when it comes to the Bruteforce attacks, which we'll be using later today, it's a lot faster and more convenient compared to Burp Suite community. So that's why I would recommend you using this tool. You can actually use Burp Suite if you want to, but it's going to take you a little bit longer to complete the room. We have port 22, which is SSH, typical. We have port 25, which is SMTP, port 110, which is POP3, 143 IMAP, port 993 and 995. These are also POP3 and the IMAP. And we also have some irregular ports open, which is port 4000 and port 50,000. In the regular pen testing phase, we have to go through each of the port and enumerate these services to find some vulnerabilities. But because we are doing a web app pen testing, we're focusing on the web version. My intuition would tell me that go straight to these two irregular ports, which is port 4000 and port 50,000. Let's open that in the browser. So 4000, here we have login sections, signing using guess, and take a look at this one. Restricted portal right here. We also have a login panel. Do we have anything else? View page source. Do we see any irregular things? We don't have anything. Close it. We have home page. Okay, so we have an application of port 4000. Before we dive deep into this application, let's do a directory enumeration on this port 4000. There, http include.thm port 4000, and let it run in the background. Let's go back to the application. So we have my profile right here, and we have two friends. Let's view profile. Based on the display of the application, the intuition tells me that there's going to be something to do with prototype pollutions, because on the page right here it shows us ID, the name, guest, age, 25, country, the albums, is admin, everything. So it reminds me of the prototype pollutions where you can actually inject malicious JavaScript code or properties into the objects. Let's explore these two input fields. Recommend type, let's say activity type, and then activity name. Let's see what it does. So we have a new field right here. What happens if we input another one? A name 2. So we have a different property. Okay, so what if we want to try to change the value of this A type property? A type property, a name change. So we can actually modify the value of this property. This immediately tells me that I can try changing the values of isAdmin to true. Alright, so let's try doing that. IsAdmin true. And we see, oh great, here we have some additional tabs right here. We have API. Let's take a look at this API. Okay, let's see. We get HTTP internal API. We have some security. Okay, great. We got some information right here. We got some secret key, super secret key 123. We also have another API call which reveals the reveal username admin. It doesn't show anything. Sysmon app username. Okay, so this one might be useful for us to log in this application right here, the Sysmon. So we know the super username is administrator, and for this app is admin. Okay, let's copy this one. So we have a new node right here. Okay, so what else do we have? Let's go back. Home page. Let's see friends right here. Can we click on a friend? No. Let's see. Before adding the friend, I'm going to open the inspect tab right here to see the network tab. Network, add friend. See what kind of requests we have. We've got a post request. So it's a post request to the endpoint add friend, and the friend ID is 2. Look at the cookies. There's nothing much. We have some connect IDs cookies right here, so let's just note it down. Not sure if it's helpful, but let's just leave it there. Now what we have to do is to find a point where we can provide these URLs. Let's see where else we can do it. We have view profile. Can we actually check right here the profile name? Let's try that. Most likely it's not going to work because this is just a path, but it doesn't hurt. Let's see. Okay, there's nothing. Let's try settings. Aha! Look what we have, a URL injection point. So this time let's try replacing this one with the URL right here. And we got something. Nice. It looks like this one is base 64. So I'm going to copy this one, the whole thing. And open that in the service shape. From base 64 right here. Okay, so we got the password for the review app and the Sysmon username. So let's just copy the whole thing right here and put it here. Let's compare. We have the admin and then password. We have the Sysmon app username and then this one too. Okay, great. Let's try logging in this app with the admin. So we have the admin. Okay. So it's not working. Interesting. It's not working. So how about this one? 5,000. 50,000. Does it work? Log in right here. Administrator. And the password is going to be this one. Okay, we're in. And we got the first flag. Nice. Nice. What's the second flag? Second flag is what's the content of the hidden file within that var www.html. So now we're gonna have to figure out a way to get into that specific folder, look for the file name, and then display that file onto the web application. We don't know which one which. So what we're gonna have to do is trying to do the directory enumeration on this one. TryHackMe on 50,000. We got the index.php. We have the PHP myadmin, which is forbidden. We also have the server status, which is forbidden. We also have the templates and the uploads. Let's see these two folders. Templates. Alright, we have these directories. There's nothing much to look at. Footer, headers, nothing. So let's try the upload. We have the profile, which is this one. Okay. So there's nothing much. What else do we have? We also have the JavaScript, the jQuery, JavaScript. Okay, so this one's forbidden too. The JavaScript jQuery. Okay, there's nothing. Let's see what else. We have the sysmon. We have home. We were dashboard, right? Yeah. How about we try this one? Open image in a new tab. Huh. Okay. There's something right here. So looks like we have an injection point where we can try our LFI payload. Just a quick refresher, LFI stands for local file inclusion, path traversal vulnerabilities. Over here, we see there's a parameters and the values right there, so we can actually try to provide the payload. Now you can try manually, which is like this, but it's going to take time and efforts because we don't know whether it works or not. And then we also have to take into considerations that applications implement some LFI defense mechanism, meaning that these can be stripped in the backend server without us knowing. So we don't know if these characters are stripped or not because there's nothing displayed on the application. We don't know yet. This is the time we can use the tools Burp Suite or Caido. I'm going to use Caido as I mentioned earlier at the beginning of this video because Caido will provide you a very quick brute force attacks compared to Burp Suite. Let's take a look at it. First, I'm going to prepare the payload, which is right here. So I'm going to use just hide that text. So I copy that to the root folder right here, so it's easy for us to use. Here. We start. Continue as guest. And over here, we're going to create a project. Include our TryHackMe. Over here, let's go to intercept. This is similar to Bubs with intercept, where you intercept the traffic from the application. So here we have forwarding, click it. So now it's listening to our web application. On the browser, we switch this one to Caido. And we send the request. Now request is capturing Caido. Over here, right click this one and then send it to automate. This is equivalent to Bubs with intruder. Select this one. This is going to be our payload. So create one. You're going to see a yellow box which indicates that this is the positions of the payload. So what do we need? We need a file, the payload. Where do we get it? If you see right here, there's no available options. What we have to do is upload the file to Caido. You have a workspace right here. Click onto the files and then upload a new file. In this case, I'm going to be using JSON text, which is this one. Upload it. And now we can use it. Go back to the automate task, automate tab. You see, because there's only one file uploaded to the workspace, this one will be used automatically. Let's confirm anything else. We don't need any payload processing. And for the settings, let's increase the concurrencies of the number of workers onto 50. Run it. And we see 914 requests has been completed, which is pretty fast, right? If you compare to the Bubs with community, it's much faster. And we got some hits right here, 2533. Look at that. We got the content of the SC password. So we have successfully exploited the LFI vulnerability in this application. Alright, so over here, let's select this one. You see, if we were to try these payloads manually, it's going to take us a long time to finish it. So copy this one and put it here. Alright, so let's turn it off and let's go back to the application. Paste the payload. So what's next? Now we know that the application is vulnerable to LFI. Remember back in the lessons in LFI room, besides getting the content of these files, we can actually poison the logs. Usually when it comes to LFI vulnerabilities, there are two places to look for the logs to poison. So the first place you look at is var.log.apache 2.logs, not access.log. And the second place you look at is var.log. What was it? Off, was it? Yeah, .log. So these are the two places. So let's take a look at them. So instead here, we use var.log apache 2 access.log. We get no hits. So how about log? Okay, we got something. So let's take a look at this one. Sessions open for user root by. Okay. We have timestamp right here, IP cron user session close for root. It looks like this one is recording the SSS connection. We can actually confirm that by trying to have SSS remotes. Oh, by the way, why do we have to do this? We got the... Okay, so let's try SSH root include.thm. Yes. Let's try just, you know what, let's try this one. Hopefully it works. Okay, it doesn't seem to work. But it doesn't really matter at this point, because regardless of if we fail or successfully log in, whatever actions we just performed will be logged into this page. So when we refresh this page, we should see our actions right here. Close by authenticate user root at our current IP address. Is that correct? Yes, 10.66.118.20. This is our attack box IP address. We can confirm this records all the logs from SSH connection. The next question is, how do we poison this log? We'll try one time. SSH info/lab include.TryHackMe, and of course nothing's going to work. Refresh the page. We're gonna see my username right here. I'm going to try poisoning the log by remotely execute a PHP code. PHP info at include.thm. Okay, so we got the error contains invalid characters, meaning that we can't really inject this malicious PHP code into that. So what other things we can try is try to make a netcat connection, lcnc include.thm on port 22, and let's say hello from info/lab. Let's refresh the page. Okay, look what it is. We have a failed password for invalid user info/lab right here, and we also have some key exchange identification glance set by invalid protocol identifier, hello from info/lab. Okay, it looks like this one accepts special characters, meaning that we can try to inject some malicious code. So let's try that. Same thing, and now I can try refresh the page. Look, we have successfully executed code in the backend. Alright, let's see. We can use the same thing. Okay, what do we get? This looks like a text that we're looking for. So copy this one. System. refresh the page, and we got a flag. Boom. Alright, okay, so that's it for the room today. It's a little bit short compared to any other videos, and I hope you enjoy this room. If you have any question, or if you get stuck at some points, feel free to put a comment below and I'll be happy to help. Thank you very much, and I'll see you next time. Bye.